Page 3, last page. All right, complete the table below describing the mixtures. Let C represent pounds of banana chips and N represent pounds of new mix. I don't think I'm going to make you actually do a table or have any questions on the test that have a table like this you have to fill out, and this is not the way that I would do the problem, but since this is the way the test has it, let's go ahead and do it this way. We're told up here it says grocery store has 12 pounds of trail mix. Okay, so that's easy. I'll look here, quantity, that's like how much, right? 12 pounds, so I'm just going to put 12 in there. That is 10% banana chips. Okay, so I've got 10%. I'll just write that as 0.1. I'll go ahead and convert it to a decimal. The store's manager would like to add banana chips to bring a new mix up to 25%. Okay, so let's just take a look first at like how many banana chips we have in the old mix. And all you would have to do is just multiply 12 times 0.1. And so in the old mix, it's 1.2 pounds of banana chips. Okay, the quantity of banana chips, they told us to use C, so we'll use C for that. And in this case, like let me just jump down here. Let's jump down to the new mix. That's really what we want to take a look at here. N. This is the new mix, N. And what we know is that 25% of the new mix will be banana chips, and so we'll put 0.25 in there. And then the amount of banana chips will just be 0.25 times however many pounds that new mix is. We don't know yet. And so when we're looking at just like this middle column, it's like, okay, well, what percentage of the banana chips are banana chips? It's like 100%, right? So that's just 1. And so that might be kind of confusing, but this middle row I don't think is all that important. Maybe I'm wrong. But you do the same thing, like C times 1 is C. Like we're multiplying this column times this column to get that column. Okay, so that's just the setup. That's all 18, I think, wants us to do. Okay, now 19. Write and solve a system of equations to find out how many pounds of banana chips the manager needs to add. Okay, so first of all, we know that we've got 12. He wants to add some amount, C, we don't know, and that's going to total the new amount. There's our first equation. The 12 pounds plus some amount of banana chips will equal the new mix. Okay. We also know, looking at this column here, we've got 1.2 pounds of banana chips, and we're going to add some chips to those, and that's going to equal this right here. We want 25% of them in the new mix to be banana chips. So now we've got our two equations, our two unknowns. I think I'll go ahead and use substitution here, so I can, let's say, solve this. Well, I know what N is, right? I guess I don't have to solve. I know what N is. N is 12 plus C, so I can just substitute that right into there. And this would be 1.2 plus C equals 0.25 times N. I know what N is. It's 12 plus C. Okay, and so after we simplify stuff, what we'll end up with is 1.2 plus C equals 3. 0.25 times 12 is 3. Plus 0.25 C. And we'll just keep simplifying. What we would eventually end up with, if I subtracted 0.25 C from this side and subtracted 1.2 from 3 on this side, I would end up with 0.75 C equals 1.8. And if you solve that for C, which hopefully you can do now without too much trouble, it would just be C would equal 2.4 pounds. And so that's what needs to be added to the mix. We need 2.4 pounds of banana chips to be added to get 25% in the new mix. All right, last problem. Write a system of inequalities represented by the graph. It's kind of hard to tell. This is the shaded region right here. That's the shaded region. Okay, so one thing, if I'm doing a problem like this, the first thing I look for are the y-intercepts. I've got a y-intercept here, and I've got a y-intercept there, because that's really useful information. I especially like this one. When I have a y-intercept that's at 0, 0, that means all I need to know is the slope. That's all you need. For this line right here, all I need to know is the slope. And if I look at it, it looks like it's going down 1 over 2, down 1 over 2. So the slope looks like it is negative 1/2, down 1 over 2. So this line would be y. Now here I have to be careful because it's an inequality. It's not inequality, right? This is a solid line, and it's shaded below the line. So that is going to be less than or equal to. And since I know my slope is 1/2, it's just going to be negative 1/2 x. That's it. Because the y-intercept is at 0, 0. So there's nothing else I need to do for that line right there. That's good. All right, this one's going to be a little bit harder because the y-intercept looks like it's at where? 4. That's plus 4. So the b for the second one, the y-intercept is going to be 4. Okay, so now let me see if I can figure out the slope. And this one, it looks like it's just going up 1 over 1, up 1 over 1, up 1 over 1. So the slope is 1. All right, so not too bad. So I do my y. Again, it's an inequality. This one's a dotted line. So I don't want to put the greater than or equal to or less than or equal to sign under it. But again, I have to look, okay, where is this shaded? It's shaded above the line, the dotted line. If I look at the dotted line, it's shaded above the dotted line. That means it's going to be greater than. And then I've got my slope. It's just 1, so that's 1x, but I'm just going to write x because that's usually what we do. The y-intercept is 4 plus 4. So there are my two equations right there. It would be this guy right here and this guy right there.